Parabolas. Although we have already talked about graphing parabolas, we now approach it from a different perspective. The geometric definition of a parabola is that it is the set of all points in the plane that are equidistant from a fixed point F called the focus and a fixed line L called the directrix. So if you look at the graph we have here, which is what we would expect when we talk about a parabola, there is a point here on the inside of the parabola, if you will, and a line on the other side of the parabola, and every point on the parabola is the same distance from that fixed point and from that given line. And this is the true definition of a parabola. And no matter where you select a point, the distance from here to here is always the same as the distance from here to here. And we won't derive the formula for the equation of a parabola, but it's actually not that difficult to do since it just involves using the distance formula. So first, let's talk about a parabola with a vertical axis. So when we say a vertical axis, we're talking about a parabola that opens either up or down. Let's assume for now the vertex is at the point 0, 0. The focus is at the point 0, P. So 0P could be up here, or 0P could be down here, depending on whether P is positive or negative. If P is positive, the parabola opens upward. If P is negative, the parabola opens downward. And the directrix is y equals the opposite of P. In this case, the equation of the parabola is x squared is equal to 4p times y. Let's go ahead and look at an example. Here we want to find the equation of a parabola with the vertex at the origin and focus at the point 0, 2. So I'll just sketch a little graph here. We have the vertex at the origin and the focus is at the point 0, 2. And that means the directrix has to be the same distance on the other side of the vertex. So if the focus is here, the directrix has to be a horizontal line going through -2 on the y-axis. So here is the directrix. Now the equation of the parabola is x squared is equal to 4p times y. And we know that p is the distance from the vertex to the focus. So p is this distance right here. And in this case, p is equal to 2. And I really shouldn't say it's the distance. It is the distance, but except that when your focus is down here, then p would be negative. So p is the y-coordinate, if you will, of the focus here. And so since we know that p is equal to 2, if we plug in p equals 2 here, we're going to get x squared is equal to 4 times 2 times y, or x squared is equal to 8y. Now, if we want to sketch its graph, we need to have at least one other point, right? So we know the graph goes something like this, but if we want an accurate graph, we should choose another value for x or y. So for example, if I choose y equals 2, that's going to give us x squared is equal to 8 times 2, which is 16, which means x is equal to plus or minus 4. So two other points on the graph would be the point 4, 2, and the point -4, 2. And the sketch of the graph goes something like that. In our next example, we want to find the focus and the directrix of the parabola y equals -x squared and sketch the graph. Well, we can actually do the graph pretty easily. We should all remember that graphing y equals -x squared is going to give us a parabola that goes through the origin. And if x equals 1, y will be -1. If x is 2, y will be -4. And then we have a mirror image here on the other side. And so the graph is pretty easy to get. But what about the focus and the directrix? So we know the focus is somewhere in here, and we know the directrix is some kind of a line on the other side. Well, to figure this out, you have to remember that x squared is equal to 4p times y. This is the standard formula. And in this case, we have y equals negative x squared. If we multiply both sides by -1, that gives us x squared equals negative y. And if you compare these two formulas, so x squared equals negative y and x squared equals 4py, then that means that 4p has to be equal to -1. And if 4p equals -1, this means that p is equal to -1/4. And what that tells us is that the focus is 1/4 of a unit away from the origin. And of course, the focus is right down here. And so that point is going to have coordinates 0, -1/4. And then the directrix will just be y equals +1/4, just on the other side of that vertex. We can also talk about a parabola with a horizontal axis. The main difference is that in the equation, x and y reverse roles. So the equation is now y squared equals 4p times x, but everything has the same meaning. So if you have a horizontal parabola, it's either going to open to the right or it's going to open to the left, and that just depends on whether p is positive or negative. And the directrix, of course, now will be a vertical line just on the other side of the parabola. Now, in this case, of course, P is going to help us locate the focus, which is horizontally located from the vertex. Let's take a look at an example. Suppose we have 6x plus y squared is equal to 0. If you solve for y squared, we get y squared is equal to -6x. And if you compare this with the formula y squared equals 4p times x, then this means that 4p must be equal to -6. And so p is going to be -3/2. So we know that the vertex is at the origin. The focus is going to be located to the left of the vertex because p is negative. So -3/2 units is -1.5. So there's your focus right there. And the directrix is going to be just on the other side, but remember that's a vertical line in this case. And so this vertical line will be x is equal to +3/2. So again, focus, that's just going to be the point -3/2, 0. Directrix is going to be the line x is equal to 3/2. And then the graph of the parabola, we don't actually have to use a graphing calculator. We'll talk about that in just a minute. But again, we could just graph it by choosing some value for x and then solving for y. So for example, if I choose, in this equation here, if I choose x equals -6, this is going to be y squared is equal to -6 times -6, which is 36, which means y equals ±6. So when x equals -6, y is going to be +6, and also y is going to be -6. And then we can sketch the graph of the parabola, which goes something like this. Now, what about graphing it on a graphing calculator? Most of the time when you graph something on a graphing calculator, your graphing calculator is going to say y equals, and then it will have a blinking cursor for you to type in what y is equal to. But notice in this case, since y squared is equal to -6x, you have to solve for y by taking the square root of both sides. And this is going to give you y equals plus or minus the square root of -6x. So to graph it on a calculator, you actually have to graph two things. You have to graph the square root of -6x, and you have to graph negative square root of -6x. And that's going to graph your parabola in two parts. It's going to graph the upper half, that'll be this one, And then it's going to graph the lower half, and that will be this one. So just a little tip there for plugging things in on your calculator. If you have to take a square root of both sides, because you have a square there, then you're going to get plus or minus, and that means it has two parts. One other thing to discuss before we move on is something called the lattice rectum and something else called the focal diameter. So when you have the graph of a parabola and you have the location of the focus, if you draw a line segment through the focus touching both sides of the parabola, this line segment is what is called the lattice rectum. And its distance is called the focal diameter, or I should say its length, right? So the distance from here to here is what we call the focal diameter. And the nice thing about this is the focal diameter is always equal to the absolute value of 4p, which is really nice because when you have the equation of a parabola, either y squared equals 4px or x squared is equal to 4py, the focal diameter is just the absolute value of this number that is either in front of x or in front of y. And it gives you a really nice and easy way to be able to graph parabolas. So in this next example, we want to find the focus, the directrix, and the focal diameter of the parabola y equals 1/2 x squared, and finally sketch its graph. Okay, so got to be a little bit careful. We have y equals 1/2 x squared. Remember, for a parabola in this context, we always want it to be solved for the squared variable. So we need to express it as x squared is equal to 4p times y. So to do that here, I'm going to multiply both sides by 2. And if we do that, we get x squared is equal to 2y. So this number right here, that 2, must be equal to 4p, which means p is equal to 1/2. Now we know this is a vertical parabola, right? Because it's x that's being squared instead of y. And we know its vertex is at the origin. Now we know the focus is 1/2 unit above the origin, so it's right here. And then we also know that the directrix is a line just on the other side. And now with the focal diameter, which we know is equal to the absolute value of 4p, which in this case is the absolute value of 2, right? Because remember, 4p is this number in front of y here. That tells us the distance through the focus to either side of the parabola. So if the distance is 2 units, that means we're going to go 1 unit in this direction and 1 unit in the other direction. So if I do that, 1 unit to the right puts us here, 1 unit to the left puts us here, and now we can graph that parabola. Okay? And this distance from there to there, that's your focal diameter. And one final example, this is sort of an application of parabolas. One thing that's nice about parabolas is that they are used in the real world. They're used in light fixtures, they're used in satellite dishes, etc. But what happens is when you have a three-dimensional parabola, like the one that you see here, when something comes in to touch the parabola here, it's always directed to the focus. No matter where it comes in and touches, it's always directed to that focus. So in this case, we have a searchlight that has a parabolic reflector so that it forms this sort of bowl shape. It's 12 inches wide from rim to rim, okay, so 12 inches across, and it's 8 inches deep, so 8 inches from top to bottom here. If the filament of the light bulb is located at the focus, how far from the vertex of the reflector is it? So in other words, if the filament in the light bulb is at the focus, how far is it from here to here? So to do this problem, it would help to have sort of a two-dimensional analogy of what's happening here. So let's imagine that this parabola, if we're looking at it from the side, has its vertex at 0, 0, and it's 8 inches deep. So let me go up to 8 here. And at that point where it's 8 inches deep, it's 12 inches across. So it's going to be 6 inches to the right and 6 inches to the left. And so that parabola looks something like this. And I won't draw the rest of the parabola because in this case, this represents the light bulb fixture here. Now we know the equation of this parabola has to be x squared is equal to 4p times y. And what we want to know is where is the focus? So we know the focus is somewhere in here, but the question is exactly where is that location? So we need the value of p because p tells us how far we need to go. So what we're going to do to figure out p is we're just going to plug in a value for x and a value for y. And I can do that by simply using one of the points on the parabola. So I'm going to use the point 6, 8. So that is x equals 6 and y equals 8. And that gives us 36 is equal to 32 times p. And then we can solve for p by simply dividing both sides by 32. And then canceling the 4 there in each of those, we get p is equal to 9/8. So p is the distance from the vertex to the focus. And that distance is 9/8. So it's just a little bit above 1. So the location of the focus is 0, 9/8. And the question, how far from the vertex is it? Well, it's that. It's 9/8. And this is measured in inches. And that concludes this video lesson.